The question says that a Cassegrain telescope uses two mirrors as shown in figure 9.26. Such a telescope is built with the mirrors 20 mm apart. If the radius of curvature of the large mirror is 220 mm and the small mirror is 140 mm, where will the final image of an object at infinity be? So when the object is at infinity, what is the position of final image? We have to calculate this. Given that the focal length of the larger mirror, I have denoted it as 1, is given as 110 mm. We have been given the radius of curvature, so we can deduce the focal length from that, and which will be equal to radius of curvature divided by 2. So focal length of the larger mirror is going to be equal to 110 millimeter, and the focal length of the smaller mirror is going to be equal to 70 mm, and they are positioned 20 mm apart. So for the object at infinity, the image formed by the first mirror is going to be at the focal length of the first mirror, and since the focal length of first mirror is 110 mm, so the image position is going to be equal to minus of 110 mm. I have denoted it as V1. So the value of OV1 is going to be equal to minus of 110 mm. Now this image is going to act as a virtual object for this second mirror. Now since second mirror is positioned 20 mm in front of the first mirror, so the object position for this second mirror is going to be equal to 110 minus of 20, and with sign convention it is going to be equal to minus of 90 mm. So for this second mirror, we had to calculate the position of final image, that is V. So in this mirror formula, we haven't given the value of F, and we know the value of U now, that is equals to minus of 90 mm. So we can easily calculate the value of V. So let's calculate using the mirror formula. So 1 by V plus 1 by equals to 1 by F, and 1 by V would be equal to 1 by F minus of 1 by U, and minus of 1 by 90 would be equal to plus of 1 by 90, and thus calculating we will get the position of final image, and that is 315 millimeter in front of the mirror of the smaller radius. Thank you.